The night sky is lying to you. Every star you see, every glimmer, every streak of light is a message from the past. The remnants of suns that may have died before humans ever learned to speak. When you look up, you're not seeing the universe as it is. You're seeing it as it was. A snapshot frozen in time, billions of years old. It's beautiful, it's vast, and yet it's a lie. Because between those familiar stars lies something else. A darkness so immense, so powerful, that we can't even measure it. This darkness isn't an empty vacuum. It is the vast, hidden majority of everything. Today, we are going to travel there, to the edges of what humanity can currently see and beyond. So be prepared to ask the ultimate question. What truly lies in the depths of space that we haven't explored? When we talk about the universe, what we're really talking about is the section in space we can actually see. Astronomers call it the observable universe. That's a bubble of space where light has reached us since the beginning of time. Now, picture yourself standing in a dark field at night, holding a flashlight. The light from the flashlight forms a glowing circle beside you. You can see what's inside that circle, the grass, the trees, maybe the fog. But beyond that, it's total darkness. Not because there's nothing there, but because the light hasn't reached that far. That's our current situation in the cosmos. Our flashlight is the light from the Big Bang, which has been traveling for over 13 billion years. And everything it's showing is our visible universe. The amazing part? Even though the universe is billions of years old, the visible universe stretches about 46 billion light years in every direction. That's because space itself has been stretching, expanding like bread in the oven. And that is how galaxies move apart in our universe. So when you or I look through a telescope, we're not just seeing distance, we're seeing time. The further we look, the older the light we're catching. The light from our closest stars takes just years to reach us. From Andromeda, it's just 2.5 million years. But some of the faint galaxies captured by the James Webb Telescope, that light left its source over 13 billion years ago. That means right now, when you look at those galaxies, you're seeing them as they were when the first stars in the universe were forming, long before our planet even existed. Astronomers estimate there are about 2 trillion galaxies, each filled with hundreds of billions of stars. And that's just the part that we can see. Beyond the edge of our observable universe, there's more, maybe infinitely more. But light from those regions hasn't even had enough time to reach us yet. And just beyond it lies everything that we can't see. The real uncharted depths of space waiting for their light to reach us. Did you know that even inside the universe we can see, most of it is invisible? Everything we've ever detected, stars, gas, dust, planets, makes up only about 5% of the universe. The other 95% is actually dark matter and dark energy. Every galaxy you see is being held together by something unseen. Without dark matter, galaxies would tear apart by themselves. But what is dark matter? When astronomers measure how fast stars orbit the centers of their galaxies, they find those stars are moving too fast. At those speeds, the galaxies should fly apart like planets escaping a star's gravity. But they don't, because something is holding them together. That something doesn't emit light, it doesn't absorb it, and it doesn't reflect it. It's completely transparent, but it has mass. And that mass generates gravity, which binds galaxies and clusters into place. Imagine tossing a bunch of glitter into the air. It would form a loose shape, but it'd quickly scatter unless there's an invisible net catching it. That net is dark matter. Even though we can't see it, we can map where it must be by watching how its gravity bends light from distant galaxies, a phenomenon called gravitational lensing. It's like watching light bend through glass, except the glass isn't really there. But no one knows what dark matter actually is. Some think it's made of exotic particles, otherwise known as weakly interacting massive particles that sometimes collide with normal matter. Others suggest axions, hypothetical particles that might fill the universe. But so far, not a single dark matter particle has ever been caught in a detector. So if dark matter is the glue that holds everything together, what's dark energy? Well, in the late 1990s, astronomers studying distant supernova made a shocking discovery. The universe isn't just expanding, it's also speeding up. Something is pushing galaxies away from each other faster and faster. And the further apart they get, the faster they keep moving. That something is dark energy. Nobody knows what it's made of. Some think of it as energy built into space itself. Think of it like stretching a rubber band. The more you stretch it, the tighter it pulls back, except dark energy works in reverse. The more space there is, the more dark energy seems to appear, driving the expansion even faster. Dark energy makes up about 68% of everything. But it's not just pushing galaxies away, it's reshaping it. And if it keeps growing stronger, the universe might face something called the Big Rip. This is when expansion accelerates so much that galaxies, stars, planets, even atoms are torn apart. But even if that never happens, dark energy guarantees something else: emptiness. Billions of years from now, galaxies will be so far apart that their light will never reach each other. An observer in the future might look up at the night sky and see nothing. No stars, no galaxies, just darkness. Between the clusters of galaxies lie cosmic voids, and these are enormous. Each void can span tens to hundreds of million light years across. If you were to fly through one at the speed of light, it would take your entire life, and you would never pass a single star. Voids are like the oceans of the galaxy, endless, dark, and almost empty. Astronomers have mapped these voids using surveys of millions of galaxies, and what they found is actually crazy. About 80% of the volume of the universe is made up of these empty regions. Turns out most of the cosmos isn't made of stars, it's made of nothing. But voids aren't empty. Well, not completely. If you were floating inside one, you'd still find a few stray hydrogen atoms scattered here and there. But on average, there are only a few atoms per cubic meter. And to put that into perspective, it's like a city where the buildings are billions of kilometers apart. It sounds pretty empty, right? But every so often, in the middle of a void, you can find a single, lonely galaxy. These are called field galaxies, and they live millions of light years away from each other. They might go billions of years without another galaxy ever passing them. Inside those galaxies, stars are born, but they also die. You might be thinking that voids seem like wasted space, but they actually play a crucial role in our cosmos. Think of them as the lungs of the universe. If the universe were perfectly uniform and evenly spread, then galaxies wouldn't form at all. So in a way, the emptiness creates everything. Voids are what allowed the galaxy to form. But these voids are also growing because the universe is expanding and accelerating. The empty spaces are stretching faster than ever. The galaxies are drifting apart, and eventually, everything we see and know today will fade. The universe will become more void than anything else, just a silent, dark place. It's dreary, I know, but there's something peaceful amongst the emptiness. The voids remind us that existence isn't just made of things, it's made of spaces between things. And those spaces are what make the universe possible. We have mapped the stars, sent probes beyond our solar system, and measured light from galaxies born billions of years ago. But no matter how far we reach, there's one boundary we can never cross. It's called the cosmic horizon, the ultimate edge of what we can ever see. Light travels at a fixed speed, about 300,000 kilometers per second. That is insanely fast. Yet, in a universe this large, it's not fast enough. When we look out into space, we're really looking back in time. Every extra light year we look at means an additional year of history we're seeing in reverse. So the furthest we can see, over 46 billion light years away, isn't a place we could ever reach. It's a limit of time itself. Beyond that horizon, light from more distant regions hasn't had the time to reach us since the universe began. It's like we're standing in the middle of a sphere that's expanding, and the outer edge is always racing away faster than light can keep up. But the edge isn't just a wall. It's not like space just ends there. There's far more universe beyond it, maybe infinitely more. We just can't see it yet, because its light hasn't had the chance to arrive. Picture yourself on a dark shoreline, with lightning in the distance. You can only see as far as the light travels, but you know the ocean goes further than what you can see. That's what the universe is like for us. And as we spoke about before, space itself is expanding, and that means the horizon keeps moving. Every second, new regions of the universe slip beyond where we can see. Their light stretched until it fades into invisible infrared, then microwaves, then silence. It's not just that we can't reach those places, they're literally being pulled away faster than light itself. The furthest thing we can see isn't a galaxy or a star, it's a faint glow called the cosmic microwave background. It's the leftover heat from the Big Bang light that's been traveling towards us for nearly 14 billion years, stretched and cooled into radio waves. We're not just peering at stars when we look at them. We're seeing the universe as a baby, a time when it was only about 380,000 years old. Beyond that, light simply didn't exist yet. The universe was too hot and dense for it to travel freely. So even with our best telescopes, the cosmic microwave background is like a cosmic curtain. It's the oldest light we will ever see. In the far distant future, billions of years from now, the only galaxies visible from Earth will be the few in our local group. The Milky Way, Andromeda, and their smaller companions. Everything else will have drifted so far that their light will never reach us again. Future astronomers might look at the night sky and see only a handful of galaxies, never realizing that once the universe was full of them. We might never know what lies beyond the cosmic horizon. Maybe it's more of the same, endless galaxies stretching forever. Or maybe something entirely different. Some believe that the universe is infinite and flat. If that's true, then what lies beyond the cosmic horizon is just more universe, more galaxies, more clusters, more cosmic web, continuing forever. In an infinite universe, every possible arrangement of matter could eventually repeat. Somewhere insanely far away, there could be another region almost identical to ours, another Earth, another you, but maybe the universe isn't flat. Maybe it curves back on itself the way the surface of this planet does, only in higher dimensions. And if that were the case, then in theory, you could travel in a straight line through space and eventually return to where you started because space itself loops. It's the same way sailors used to circle the Earth without ever finding an edge. Space could be doing the same thing on a cosmic scale, finite in size but with no edges. Some research suggests that the universe is extremely close to flat. But even being extremely close to flat could mean the universe has a gentle curve so vast that we'd never notice it, even across the entire observable universe. There's another idea that has become exceedingly popular within the last few years, the multiverse. We've all seen the multiverse portrayed in movies, worlds colliding, infinite versions of ourselves. But what if those stories aren't entirely fiction? In this theory, our universe might just be one bubble in an infinite number of other universes, each born from its own Big Bang with its own laws of physics. Some could be short-lived flashes of energy that vanish in a heartbeat. Others might expand forever, like ours. But some might have entirely different versions of reality, different particles, forces, or even dimensions of space and time. If there really is a multiverse, the cosmos we see isn't the universe. It's just our bubble, one universe among maybe infinite others. There's one more possibility, the simplest and most haunting of all. Maybe there is nothing beyond the edge. Not because the universe stops, but because space itself ends where light can no longer exist. A cosmic horizon beyond which time itself loses meaning. Not a wall, not a border, just a point where existence fades into mathematical silence. We may never know which of these theories are true. Is there a multiverse? Is the universe really infinite and flat? Scientists will try to find these answers on every working day. What do you think is out there? What theories do you agree with, and what theories do you oppose? Let us know in the comments below. Thanks for watching, and we'll see you next time.